Okay, so far we've talked about almost everything with the unit circle, and we introduced the three reciprocal trig functions, so we're up to 6 trig functions. We know about radians, but we haven't talked about them with the unit circle, and that's what part of this video is about. And then the other thing we need to talk about is what if we're given a negative angle or an angle that's outside of our full 360 degrees or full 0 to 2 pi of our circle? Well, how do we handle something like that? So that's the last thing that kind of wraps up the unit circle here. Okay, so for the unit circle, when we think about radians, we know that 0 degrees is the same thing as 0 radians. And we know that there are 2 pi total radians in one circle in 360 degrees. And if I divided that 360 by 4, I would have 90 degrees. And if I divided 2 pi by 4, I would have pi over 2. So in our first quadrant, we go from 0 to pi over 2. And if we divided pi over 2 by 2, right, if we divide 90 by 2, we get 45. If we divide pi over 2 by 2, we get pi over 4. So this angle here is pi over 4. If we have the entire pi over 2 and we divide it into thirds, then we would have, well, pi over 2 divided by 3 is pi over 6. Okay, so that means this angle is pi over 6. And then this angle here is another pi over 6. So it's 2 pi over 6. 2 pi over 6 reduces to pi over 3. So we need to become just as comfortable using radians to describe the angles on a unit circle and angles in general as we are with degrees. Now, it's definitely true that if you're given a problem when we get into something called vectors later in a semester, and it says like 42.3 degrees or something like that, there's no great way to represent that with radians. The value of using radians is really when we're talking about these common angles, and you can represent 42.3 degrees as radians. But it's not as some nice numbers. So what's so great about using radians in the unit circles, we deal with these nice numbers all the time. And just like there are reference angles with like degrees, of course there's also reference angles with radians. So if we say these coordinates indicate to us that that's a pi over 3, a pi over 6, or also just 30 degrees, right? That's a pi over 6 angle. Well, this angle over here, which is 5 pi over 6, that is still a pi over 6 or a 30-degree reference angle over there in quadrant 2. And then this angle over here, which is 7 pi over 6, like we could even count the pi over 6s, right? We had 1, we had 2, we had 3, we have 4, we have 5, we have 6, we have 7. Okay, that's still a pi over 6 reference angle or a 30-degree reference angle, but it's in quadrant 3. And then the same thing with this last one, right? That would be 11 pi over 6. We know that a full 2 pi would be 12 pi over 6. So if we went 30 backwards, then we would have a 30-degree reference angle in quadrant 4, and we'd have 11 pi over 6, 12 pi over 6 minus 1 pi over 6. So we still have these reference angles, and it still works out for us where we don't need to like memorize all these things because these angles repeat. And what that means that they repeat is that we actually going to start calling trigonometric ratios trigonometric functions pretty soon, because that's what they are. And they are what are known as periodic or cyclical or circular functions, which means their values, their output values, they repeat themselves on regular intervals. And if you think about why is that like that is like very reminiscent of what happens with a circle. If you're going around this circle, like you have different xy values, different xy values, different xy values, all these different xy values, different xy values. But then when you get back to where you started, you're going to start repeating xy values again. And so if you were asked, like, look, this is 405 degrees. How do you draw a 405-degree angle? Well, you would draw, have to be greater than 360 degrees. Like, what? How does that make sense? Well, it's because it just is going to start repeating itself. So instead of drawing a 405-degree angle, we can say, well, 405 degrees is greater than 360. So let's subtract 360 degrees. And what do we get? We get 45 degrees. So this right here is a 405-degree angle, basically. I mean, this is a 405-degree angle, but it's effectively, for our purposes, our calculation purposes, it's a 45-degree angle. So this is just a 45-degree angle, and we can find all the trig ratios for a 45-degree angle. So when you see an angle greater than 360 degrees or greater than 2 pi, that's how you deal with that. Well then, what about negative? Well, we've talked about how clockwise rotation in math is negative and counterclockwise rotation in math is positive. It has to do with how sundials work, and it has to do with something called the right-hand rule, which I explained in a previous video. But if we draw that now, okay, let's draw this 13 pi over as negative 13 pi over 6. Well, instead of going off that direction, I'm going to go in the negative direction. And we say 13 pi over 6. Wait, 12 pi over 6 would be a full 2 pi, so I would go my full 2 pi and then one more pi over 6, which is going to be, like, maybe you're looking at this and you're like, oh, that's a 30-degree reference angle in quadrant 4. That's 100% what it is. Okay, so this is really just pi over 6 right here. It's a negative pi over 6. This is the same thing as negative pi over 6, which is the same thing as a negative 30 degrees. 8 pi over 3. So now we're dealing with positive angle, right? This is positive, but it's greater than our 6 pi over 3, because we know 0, our angles in a unit circle are anywhere from 0 to 2 pi, right? And so 8 pi over 3, well, 6 pi over 3 is how we would represent 2 pi. 8 pi over 3 is greater than that. So if we think about that, that's kind of like going, all right, let's go our full 2 pi, our full 6 pi over 3s, and then 2 more pi over 3s. So we're actually out over here. This is 2 more full pi's over 3s. And so that would be, hopefully you're looking at that and you're like, oh, that looks like a pi over 6 right there, or a 60-degree reference angle in quadrant 2. And that's exactly what it is. This is just like 2 pi over 3, which is a 60-degree reference angle in quadrant 2. And then lastly, if I have negative 630, that again just means we're going to go now the opposite direction. So if you go negative 360, right? And then what is 630 minus 360? I don't even know. It's 270, right? Yeah, 270. Okay, so we did our negative 360, and now we're going to go another negative 270. So we're actually up here. So that would be our angle. It's the same thing as, it's the same thing as a negative 270-degree angle, which is the same thing as a positive 90-degree angle. And so these negative angles, we can always come up with a much more simple positive version of them. And really big angles beyond 360 degrees or beyond 2 pi, we can come up with a much simpler version of it, and then we can do our evaluation that way. Now there's some little more to this. It has to do with how specific functions, how periodic they are, like what is actually the period over which they repeat. Once we get some mastery of that, which is coming up, we can actually, what we just did here, we can do it a little bit more precisely. But this is still correct. So let's just get some unit circle practice really quickly, incorporating everything we know now, which includes the other 3 trig functions and radians and negative angles and angles greater than 2 pi or greater than 360 degrees. So cosine of 150 degrees, that's the same thing as let's just draw that real quick. That is the same thing as a 30-degree reference angle in quadrant 3, and cosine of 30 degrees is root 3 over 2, and so it's going to be negative because it's over here, right? This is in quadrant 2, in quadrant 3 it's negative, everything's negative there except for tangent, cotangent. So this is just going to be negative root 3 over 2. Okay, secant of 17 pi over 3. Well, first of all, 17 pi over 3 is outside of what would be my comfort zone, which is, I'm going to call that comfort zone, right? It's between 0 and 2 pi. Okay, so 2 pi and 6 is 12 pi over 6. So I have 5 extra pi's over 6. So where's 5 pi over 6? Well, it's right here. Okay, it's a 30-degree reference angle, or a pi over 6 reference angle in quadrant 2. And secant is 1 over cosine, and cosine is negative over there in quadrant 2. So this is going to be like 1 over, and then remember the x value at this point over here is going to be negative root 3 over 2. So if we flip that, we get negative 2 over root 3, and if we rationalize that, we'll have negative 2 root 3 over 3. So that would be the answer to that one. Okay, cosecant of negative 30 degrees. Boom. Okay, negative 30 degrees right there. All right, and cosecant is 1 over sine. The coordinates at this point are going to be root 3 over 2 comma negative 1/2. Cosecant, recall, cosecant of theta is the same thing as 1 over the sine of theta. And the sine of theta in this case is going to be our are negative 1/2. So 1 divided by negative 1/2, well, 1 divided by negative 1/2 is negative 2. So the cosecant of negative 30 degrees is just negative 2. All right, cotangent 4 pi over 3. So 4 pi over 3 is going to be over here, right? So that's a 60-degree reference angle, or a pi over 6 reference angle. Sorry, pi over 3 reference angle there in quadrant 3. The coordinates at this point are going to be negative 1/2 comma negative root 3 over 2. And so where tangent is y over x, cotangent is x over y. So we're going to have negative 1/2 divided by negative root 3 over 2. If we flip this, instead of dividing by a fraction, multiply by reciprocals, negative 1/2 times negative 2 over root 3. So that's going to cancel. We're going to have positive 1 over root 3. Rationalize. Okay, we'll end up with root 3 over 3. Now you might be able to do that a little bit quicker, but you still get the same answer in the end. And so cotangent is one of those ones you got to be kind of careful of. It's really easy to skip to mix up the x and the y's. Okay, tangent of negative 80 pi over 6. Oh man, why are you like this? Okay, well, first of all, let's look at this just negative 80 pi over 6. We can rewrite that right away as negative 40 pi over 3 by factoring out a 2. And then let me think. So I know that a full circle will be a 6 pi over 3. And so I can get rid of these full circles if I go around. Let me think, like if this was happening, right? I've got a negative angle, so I'd be going around and around and around and around. But at some point I'm going to cross my full circle again and have a little bit left over. So if I can keep subtracting 6 pi over 3's from this 40 pi over 3, I'll end up with a value that's between 0 and 6 pi over 3. Positive or negative, doesn't matter. Okay, so let's say, why don't I just subtract 6 of these? So I'm going to take the negative 40 pi over 3, and I'm just going to subtract 6 pi over 3's, or 36 pi's over 3's. Right? That's going to be, sorry, I'm going to add that. That's going to give me negative 4 pi over 3. Oh, okay, well now if you had just told me that it's a tangent of negative 4 pi over 3, like that'd be way nicer. And so how do you deal with that? Well, we can still have negatives, which kind of stinks, but we end up with that 60-degree reference angle, or that pi over 3 reference angle there in quadrant 2, and tangent is negative there, and it's going to be this negative square root 3. To prove that, this is going to be, it's negative 1/2 comma root 3 over 2. It's y over x, so root 3 over 2 divided by negative 1/2, or root 3 over 2 times negative 2 over 1. Boom, we got negative root 3. Okay, so this is a thought process for unit circle, and you don't have to immediately be able to evaluate these things, but you do need to immediately dive into it and start to figure out what it is, because once you do that, as long as you're comfortable with the first quadrant, you can figure anything else out. If it takes you 10 to 15 seconds for every unit circle problem, that's fine. But eventually, once you start to recognize patterns and you kind of start you start to memorize it just by repetition, not because you're like trying to memorize it, things will start to come a little faster.